Okay, so now that we have seen a couple of videos highlighting how to solve radical equations, let's do a few together here. The first problem we have is negative 10 plus the square root of x is equal to negative 6. Now, believe it or not, we could actually go into Desmos and we could graph this. In other words, I would have to put the left side of the equation on one line, and then I would just put y is equal to negative 6 on the other line, and that would give us the solution as well. But let's first of all, let's solve this using algebra, and then I'll show you how to solve it using Desmos, because that is a great way to check your homework. First thing we're going to do is we're going to try to get the square root by itself. Let's try to get the radical by itself. And in order to do that, I'm going to add 10 to both sides. So I add 10 on the left side of the equation. That means I have to add 10 on the right side of the equation. And that's going to leave me with the square root of x is equal to 4. Well, luckily, there's only one number out there that has a square root that's equal to 4. And if you don't know it, just keep going. In order to undo a square root, we have to square both sides. So we'll square the left side, and we will square the right side. And the square root of x squared is just x. So the answer is x is equal to 16. That is the solution. Let's check it and see if we're correct. Remember, the original said that we had negative 10 plus the square root of x, and we figured out that x is 16. So that's going to be the square root of 16. And we know that the square root of 16 is actually positive 4. And negative 10 plus 4 is negative 6, and that's what they said in the very beginning. So that did check. Now let's switch over and let's look at how this might be solved on Desmos. We had on the left side negative 10 plus the square root of x. And I guess I need to say y equals let me go out here, take a look. And that's what the graph would look like. And then the right side says y is equal to negative 6. And we figured out that the solution to this system is 16. And as you can see, the x value is 16. And of course, the y value is negative 6. So all we have to do is put the left-hand side on one line and then put the right-hand side of the equation on the other. And we can solve this just like we solved systems of equations in the past by graphing. So let's do another one. Let's go back to our drawing board here and see if we can figure out how to solve another problem. Let's look at the square root of x is equal to the square root of 4 minus x. And all I have to do here is just go ahead and take the square root on both sides. Well, if I take the square root on the left side, I have to take the square root on the right side. And that will leave me the square root of x squared, which is x. And on the right side, I have the square root of 4 minus x, all raised to the power of 2. And that leaves me 4 minus x. Now I'm going to add an x on both sides. That will leave me 2x on the left. That's ugly. Let's try this again. That will leave me a 2x on the left side. And of course, the negative x plus x would be 0. leaving me positive 4. And then once I divide by positive 2, I see that the x value is 2. So 2 would actually be the solution to this problem. And let's go ahead and put this into Desmos just to verify that we will get the exact same answer. So here we go. Remember, the left side said y is equal to the square root of x. And the other side said y is equal to the square root of 4 minus x. And we can see here that the green and, whoops, let me change this. This should be the square root of 4 minus x. Okay. Okay, now we can see the solution is x is equal to 2, which is what we got here. And again, all you have to do is put the left side of the equation on one line in Desmos, put the right side of the equation on another line, and just solve it just like you would a system of equations. And let's do one more. Let's do one that would be a little more challenging, perhaps. What about the square root of 79 minus 5x is equal to x minus 11. And again, luckily, we have our square root isolated by itself. That means I can go ahead and square the left side, which means I have to square the entire right side. Don't just square the 11, right? You have to square the entire right side as well. And if I solve on the left side, that will leave me 79 minus 5x is equal to, now don't forget that x minus 11 squared is actually x minus 11 times itself, right? X minus 11 times x minus 11. And I'm going to FOIL this. Some of you might use the box method, but I'm going to FOIL it. When I do the first terms, I get x times x is x squared. Then when I do the outside terms, I get negative 11x. The inside will give me another negative, which is negative 22x. And finally, negative 11 times negative 11 is positive 121. So on the right side, I have x squared minus 22x plus 121 . And now I have to solve for x. So this is going to be some old school here, right? We're going to have to set one side equal to 0. And that's going to give me on the right side, let's see, x squared. And I'm going to add 5x on both sides. So if I add 5x here, I have to add 5x here on the right side. And of course, in order to get a 0 on the left side, I had to subtract 79 on both sides. Okay, so that's going to give me x squared minus 17x, because negative 22x plus 5x, that's going to be negative 17x. Then I'm going to have 121 minus 79, and 121 minus 79 will leave me 42. And unfortunately, we're not finished, right? Now we have to, we have set this equal to 0, which means we now need to factor. So let's do that. And luckily, the leading coefficient is 1x squared, so that's going to be an x and an x. And now I'm looking for those numbers that multiply together to give me 42 that will somehow add together to give me 17. And 1 and 42 is not going to work. Can't get a 17 out of that. 2 and 21. Can't get a 17 out of that. 6 times 7 is not going to work. So what is going to do it? What can we use to figure this out? Let's keep looking here. What about 3 and 14? Because 3 times 14 gives me 42. And I can get a 17 using a 14 and a 3. This plus here says the signs are going to be the same. This sign says both negative. So I'll have a negative here and here. And I have a 3. And I have a 14 here. Now I can solve. If I multiply one number times another and I get 0, at least one of the numbers has to be 0. If x minus 3 is 0, then x has to equal 3. So there's one possible solution. And for the other part, I will have x is equal to 14. Those will be the solutions. Now remember, anytime you have a square root, you cannot have a negative underneath. And if we plug 14 in for x, 5 times 14 luckily is 70, so that's going to be okay. 79 minus 70, that's going to keep us in the positive range. So it looks to me like both of these are actual solutions. And let's check this using Desmos. Let's slide over and take a look on Desmos here. Remember, on the left-hand side of the equation, we have the square root of 79 minus 5x. So we graph that. And then on the other side, we had it set equal to x minus 11. And let's see what we have here. Well, we have only one solution. We have 14 and 3. So we need to go back and investigate why we only have one solution. And it probably has something to do with the fact that we are working with square roots. So let's take a look at that and see. Let's go back to our problem. And let's see what the problem is. It gave us the 14, right? But did it give us the 3? It did not give us the 3. So let's go back and take a look and see what the issue is. We've got the 14. For some reason, it did not take the 3. Well, the square root of 79 minus 15 now where did the 15 come from? I'm letting x equal 3. And is that going to be equal to 3 minus 11? I can see the problem already. 79 minus 15 is actually 64, and the square root of 64 is 8. And 3 minus 11 is negative 8, and since 8 is not equal to negative 8, this did not check, which means 3 is an extraneous root. We cannot use the 3. So what did we learn here? We learned that anytime we solve an equation that has a square root in it, we have got to always check our solutions to see if, because it is possible to get what are known as extraneous solutions, and extraneous solutions will not check. They're not valid solutions. Let me repeat that. Anytime we solve equations involving radicals, it's a great habit to always check your answers, because algebraically they may be correct. But when you substitute those back in, you will see that they are not always correct. And fortunately, we graphed this on Desmos, and it allowed us to go back and use this teaching moment to remind ourselves, including me, always check those solutions.